Go outside tonight and look up. Really look, not a glance, but a proper 5 minutes of staring at the stars until your eyes adjust. You'll see roughly the same sky that Sumerian astronomers mapped with such precision that modern scientists are still trying to figure out how they did it. Because the oldest civilization we know of didn't just look at the stars, they recorded planetary orbits, predicted eclipses, and described objects in our solar system that weren't officially rediscovered until the 18th century. And some of what they wrote down shouldn't have been possible for anyone to know without a telescope, which wouldn't exist for another 4,000 years. If you are settling in for the night, this is a long one. And if you drift off somewhere between Saturn and Neptune, that is perfectly fine. Subscribe and stick around, because what the Sumerians recorded about our solar system is one of the most genuinely unexplained puzzles in the history of science. To understand why this matters, you need to know what the Sumerians should have been able to see, and what they absolutely should not have been able to see. With the naked eye on a clear night, you can see 5 planets: Mercury, Venus, Mars, Jupiter, and Saturn, and every ancient civilization knew about these 5. The Sumerians had names for all 5. They tracked their movements across the sky, and they recorded those movements on clay tablets with extraordinary care. Mercury they called the jumping planet, because it moves so quickly near the horizon. Venus was the queen of heaven, associated with the goddess Inanna. Mars was the red star of death and disease. Jupiter was the white star of the chief god, and Saturn was the steady star at the edge of visible wanderers. All of this is normal. Every civilization with clear skies tracked these 5 planets. The Greeks did it, the Chinese did it, the Maya did it, the Egyptians did it. But here is where the Sumerians diverge from everyone else, because their astronomical texts describe objects that the naked eye cannot see, and not vague poetic references to distant lights, but specific descriptions with names, positions, and characteristics that match what modern telescopes have confirmed. The single most controversial artifact in this entire discussion is a small stone cylinder seal housed in the Vorderasiatisches Museum in Berlin. Catalog number VA243. This seal, dating to approximately 2300 BCE, shows what appears to be a central star surrounded by 11 smaller bodies of varying sizes, arranged in a rough circle. 11 bodies orbiting a central star. In our solar system, there are 8 recognized planets, plus the Sunday, plus the Moon, plus Pluto if you count it. The arrangement on the seal doesn't just show random dots. The bodies appear to be different sizes, and those sizes roughly correspond to the relative sizes of our actual planets. A small body near the center that could represent Mercury, a slightly larger one for Venus, 2 similar-sized bodies for Earth and Mars, and then a dramatically larger body for Jupiter. Now, mainstream archaeology has a straightforward response to this. They say the seal doesn't depict the solar system at all. The leading interpretation among Assyriologists is that the central radiant figure is simply a star symbol, common in Mesopotamian art, and the surrounding dots are decorative or represent other stars. Star symbols with rays appear on thousands of Mesopotamian seals, and they usually represent deities or celestial objects in a general symbolic way, not a specific map. This is a valid argument, and most professional Sumerologists accept it, but it doesn't fully address why this particular seal has such an unusual arrangement of differently sized bodies. Other star symbols in Mesopotamian art typically show a single star with rays, not a central body orbited by 11 objects of deliberately different sizes. But the cylinder seal is just one piece of evidence, and honestly not the strongest one. The real puzzle comes from the cuneiform astronomical texts themselves. The Mol Apin is a pair of cuneiform tablets that serve as a comprehensive astronomical compendium, cataloging stars, constellations, and planetary movements with mathematical precision. The version we have dates to about 700 BCE, but scholars believe the observations it records go back at least 1,000 years earlier, to the 2nd millennium BCE. The Mol Apin divides the sky into 3 bands: the path of Enlil in the north, the path of Anu in the middle, and the path of Ea, which is Enki, in the south. Within these bands, it catalogs 36 stars and constellations with their rising dates, and many of these correspond precisely to constellations we still use today. The Sumerians essentially created the zodiac that the Greeks later adopted, and that astrologers still reference. The 12 divisions of the ecliptic path originated in Mesopotamia, but the Mulapen also contains planetary data that goes beyond casual observation, including calculations of synodic periods, the time it takes a planet to return to the same position relative to Earth. Their calculated synodic period for Venus was 587 days. The modern value is 583.9 days, an error of less than 1%. For Jupiter, they calculated 399 days. The modern value is 398.9, essentially identical. This level of accuracy requires not just observation, but sustained systematic observation over centuries, with precise record keeping passed down generation after generation. And the Sumerians clearly had this tradition. The astronomical diary tablets found at various sites confirm continuous celestial monitoring spanning over 1,000 years. But accurate synodic periods for the 5 visible planets, while impressive, can be achieved through careful naked-eye observation over long periods. There is nothing impossible about it. The real mystery starts when we look at what they said about things beyond Saturn, the boundary of what human eyes can detect. Uranus was not officially discovered until 1781, when William Herschel spotted it through a telescope. At the time, it was the first new planet found since antiquity. Neptune was found in 1846, after mathematical predictions told astronomers exactly where to look. Pluto in 1930. These discoveries were considered triumphs of modern science and technology, proof that telescopes and mathematics could reveal what eyes alone never could. But certain Sumerian and Babylonian texts describe celestial bodies beyond Saturn that don't correspond to any known star, and their descriptions are peculiar. The Enuma Elish, the Babylonian creation epic, describes the formation of the solar system in a sequence that names celestial bodies in an order remarkably similar to their actual distance from the Sunday. It starts with Apsu, identified with the Sunday, then moves outward through bodies that can be matched to Mercury, Venus, Earth, Mars, Jupiter, and Saturn. But the Enuma Elish doesn't stop at Saturn. It continues outward and describes additional celestial bodies that the conventional interpretation struggles to account for. Now, this is where we need to be very careful, because the translation of ancient astronomical texts is enormously complex and scholars disagree on many specific readings. The word-to-planet mappings that alternative researchers use are not universally accepted, and mainstream Assyriologists caution against reading modern astronomy back into ancient myths. But the alternative researchers counter with a specific question that the mainstream hasn't fully answered. Why do the Sumerians describe a solar system with more bodies than should have been visible? Let's look at specific claims and examine the evidence for and against each one, because the details matter more than the headlines. The Venus tablets of Ammisaduqa are among the oldest astronomical records that survive from any civilization, dating to around 1600 BCE. These tablets record the appearance and disappearance of Venus as a morning and evening star over a period of 21 years, and the observations are remarkably detailed. They note the exact dates when Venus appeared on the eastern horizon, when it disappeared behind the Sunday, and when it reappeared on the western horizon. Modern astronomers have verified these observations by calculating backward, and the recorded dates match actual Venus positions to within a few days across the entire 21-year period. This confirms that Mesopotamian astronomers were doing genuine systematic science, not symbolic storytelling, but real observation and recording of celestial mechanics. If they were this precise about Venus, which we can verify, it raises the question of how much weight to give their claims about things we can't as easily verify. Now let's address the most controversial claim directly, the one that has launched 1,000 arguments between mainstream and alternative researchers. In 1976, a researcher named Jacaria Sitchin published a book claiming that the Sumerians knew of 12 celestial bodies in our solar system: the Sunday, Moon, the 5 visible planets, plus Uranus, Neptune, Pluto, and a body he called Nibiru, a planet on a long elliptical orbit that passes through the inner solar system. Sitchin's translations have been heavily criticized by professional Sumerologists, many of whom say he mistranslated key passages and imposed modern astronomical concepts onto ancient religious texts. The academic criticism is substantial. Sitchin had no formal training in Sumerian, and his readings of specific cuneiform signs are often at odds with established dictionaries. But dismissing Sitchin doesn't actually resolve the underlying puzzle, because even without his specific interpretations, the Sumerian astronomical record contains genuinely unexplained elements. You don't need Sitchin to find the mysteries. They exist in texts that mainstream scholars have translated and published themselves. If you are drifting off right now, that is perfectly fine. These mysteries will still be here waiting when you wake up. But if you are still with us, let's look at the specific astronomical knowledge that mainstream scholars acknowledge the Sumerians possessed, and that remains difficult to explain. First, the Sumerians knew that the Earth and other planets orbited the Sunday, at a time when almost every other civilization believed the Earth was stationary. The conventional history of astronomy credits Aristarchus of Samos in the 3rd century BCE as the first to propose a heliocentric model, and then Copernicus 1600 years later for proving it. But certain Sumerian texts describe the planets as wanderers that move around a central fire, and their mathematical models of planetary movement only work if you assume orbital mechanics. The Sumerians calculated the synodic period so accurately that the math implies they understood the basic geometry of orbits, even if they didn't express it in the same terms we use. Second, and this is less widely discussed, the Sumerians appear to have known that the moon was not self-luminous but reflected light from the Sunday. Multiple texts describe the moon as receiving its light from the great star, language that implies reflected rather than generated luminosity. This isn't groundbreaking by itself. A careful observer might deduce this from watching lunar phases, but it demonstrates a level of theoretical understanding beyond simple record-keeping. Third, the Sumerians produced mathematical calculations of extraordinary precision that should not have been possible without tools they didn't officially possess. A tablet known as YBC 7289, held at Yale University, contains a calculation of the square root of 2 that is accurate to 6 decimal places. Another tablet calculates the value of pi to a precision that Europe wouldn't match for another 3,000 years. Now, mathematical precision and astronomical knowledge aren't the same thing, but they suggest a civilization operating at a level of intellectual sophistication that we may be underestimating. Let's go deeper into the specific astronomical claims that cause the most heated debate, starting with what the Sumerians said about individual planets. The Sumerians called Jupiter the Great Bright Star, and they described it as the largest of the wandering stars, which it is by a significant margin. They also described Jupiter as having a family of attendants, smaller bodies that accompanied it on its path, language that some interpret as a reference to Jupiter's moons. Galileo discovered Jupiter's 4 largest moons in 1610 through his telescope. The idea that the Sumerians knew about them 4,000 years earlier is extraordinary. The skeptical response is that attendants is a theological term referring to lesser deities associated with Jupiter's patron god, not physical satellites, and this interpretation has strong support. Saturn presents a similar puzzle. The Sumerians described it as surrounded by a ring of light, language that superficially matches Saturn's famous ring system. Saturn's rings are not visible to the naked eye. Galileo first saw them in 1610, and even he didn't understand what he was looking at, initially thinking Saturn had ears. The alternative interpretation is that the Sumerian description refers to a halo effect common around bright objects in the sky, especially when atmospheric conditions create refraction. Both explanations are plausible, and this is the fundamental problem with the entire debate. Nearly every piece of evidence can be read 2 ways. But some Sumerian astronomical claims are harder to explain away with alternative interpretations, and these are the ones that keep serious researchers engaged. The Sumerians described the solar system as forming from a primordial disk of material that gradually coalesced into distinct bodies orbiting a central star. This is essentially the nebular hypothesis, the model of solar system formation that modern astronomy adopted in the 18th century and confirmed in the 20th. The Enuma Elish describes a process where formless matter is divided and shaped into distinct celestial bodies through conflict and collision, a poetic but structurally accurate description of planetary accretion. Mainstream scholars interpret this as creation mythology, not astronomy, and they have strong grounds for doing so. The Enuma Elish is primarily a religious text about the supremacy of Marduk, but the structural match between the Enuma Elish's formation sequence and actual planetary formation is specific enough to warrant explanation. not dismissal. The Sumerians also described the asteroid belt, or at least a region between Mars and Jupiter filled with rocky debris, in language that doesn't map cleanly onto any other interpretation. They described this region as the hammered bracelet, a band of broken material encircling the space between the inner and outer planets. The asteroid belt wasn't confirmed until the early 1800s, when astronomers discovered Ceres, and then hundreds of smaller bodies occupying the space between Mars and Jupiter. How would ancient observers without telescopes know about a belt of rocky debris between two planets? Debris too small and too far away to see with the naked eye. The standard answer is that the hammered bracelet is a mythological concept, a divine boundary separating the inner from the outer gods, and it coincidentally matches a real astronomical feature. Still with us, or already somewhere in that space between waking and dreaming. Either way, there is more to explore. Let's look at what might be the strongest piece of evidence in this entire debate, and it has nothing to do with cylinder seals or planet counts. The Sumerians and their Babylonian successors could predict solar and lunar eclipses with remarkable accuracy, and this ability reveals something profound about their astronomical knowledge. They discovered the Saros cycle, an 18-year period after which eclipses repeat in nearly identical patterns, and they used it to predict eclipses years and even decades in advance. To discover the Saros cycle, you need continuous eclipse observations, spanning at least several centuries, which means the tradition of precise astronomical record keeping stretches back far earlier than our earliest surviving tablets. Eclipse prediction requires understanding the relative positions and movements of the Sunday, Moon, and Earth in 3 dimensions, not just tracking bright dots across a flat sky. It requires knowing that the Moon's orbit is tilted relative to Earth's orbit around the Sunday, and that eclipses only occur when both bodies cross the same plane simultaneously. This is sophisticated 3-dimensional celestial mechanics, and the Babylonians were performing it with clay tablets and base 60 arithmetic. No other ancient civilization achieved this level of predictive astronomy. The Greeks came close but built on Babylonian foundations. The Chinese tracked eclipses but couldn't predict them as reliably. The question that haunts this field is simple. Where did this knowledge begin? Because the level of sophistication in the earliest Babylonian astronomical texts suggests they inherited a tradition that was already mature. It is as if the tradition of precision astronomy appeared in Mesopotamia already developed, with no clear evidence of the centuries of trial and error that should have preceded it. Now let's address an aspect of this story that rarely gets discussed in either mainstream or alternative accounts: the water connection. Enki, the god most associated with wisdom and secret knowledge in Sumerian religion, was also the god of freshwater, and this dual association may not be coincidental. Before telescopes, the most effective way to observe celestial objects was through their reflection in still water, which acts as a natural mirror and can reveal details that direct observation misses. Water pools eliminate atmospheric shimmer, reduce glare from bright objects, and allow the observer to look at the sky without straining their neck, enabling longer and more careful observation. Some researchers have suggested that the Sumerians used large artificial pools, perhaps in temple courtyards, as astronomical observation instruments. Centuries before anyone built a physical telescope, the Temple of Enki at Eridu was surrounded by water channels, and the Abzu shrine at its center was literally a freshwater pool, an instrument and a sacred space combined. If Sumerian priests used still water pools to observe the sky over centuries, it could explain some of the precision that seems impossible with naked eye observation alone. It wouldn't explain how they saw Uranus's moons or Saturn's rings, but it would explain the extraordinary accuracy of their planetary position data and eclipse predictions. This brings us to an interesting middle ground in the debate. Maybe the Sumerians had better observation techniques than we've given them credit for, even without technology we'd recognize. Let's examine one more body of evidence: the mathematical tablets that encode astronomical constants, so precisely they seem to come from a different era entirely. The tablet known as Plimpton 322, held at Columbia University, contains a table of Pythagorean triples, calculated with a sophistication that astonished modern mathematicians when it was first decoded. But beyond pure mathematics, Certain tablets contain numerical constants that correspond to astronomical measurements with disturbing precision. The number 12,960 appears repeatedly in Sumerian astronomical texts, and it is a factor of the precession of the equinoxes, the 25,920-year wobble of Earth's axis. Precession was supposedly discovered by the Greek astronomer Hipparchus in the 2nd century BCE. But the Sumerians used numbers that are exact factors and multiples of the precessional cycle over 1,000 years earlier. Could they have known about precession, the slow wobble of Earth's axis that takes 25,000 years to complete one cycle, without modern instruments? The honest answer is that we're not sure. The numbers could be coincidental products of the Base 60 system, or they could encode genuine observational knowledge. Base 60 naturally produces numbers that are highly composite, meaning they divide evenly by many factors, and this mathematical property could accidentally generate astronomically significant results. But the counterargument is that the Sumerians chose Base 60 in the first place, and maybe they chose it because it aligned with astronomical observations they had already made. Which came first, the number system or the celestial observation? Nobody knows, and that uncertainty is itself part of the mystery. So where does all of this leave us? What can we honestly say the Sumerians knew about the solar system? Here is what we know for certain, and this alone is astonishing. The Sumerians tracked the 5 visible planets with accuracy that wouldn't be matched in Europe for 3,000 years. They calculated synodic periods to within fractions of a day. They predicted eclipses decades in advance. They cataloged hundreds of stars and organized them into a system that became the foundation for all Western astronomy. They understood that planets orbited rather than wandered randomly. They may have understood that the moon reflected sunlight, and they used mathematics of extraordinary precision to model celestial mechanics. Here is what remains genuinely unexplained, and these are questions that mainstream astronomy has not fully resolved. Why does the Enuma Elish describe solar system formation in a sequence that matches the actual process of planetary accretion from a primordial disk? Why do Sumerian texts reference a debris field between Mars and Jupiter that matches the asteroid belt, which wasn't discovered until the 19th century? Why do their mathematical constants align with precessional values that supposedly weren't calculated until the Greek era? And why does the astronomical tradition appear in the historical record already mature, with no visible developmental phase of trial and error that should have preceded centuries of precision observation? The answers fall into roughly 3 camps, and tonight we've heard arguments from all of them. Camp 1 says the Sumerians were extraordinarily gifted observers who achieved everything through patient systematic work over millennia, and the controversial claims are either mistranslations or coincidences. Camp 2 says the Sumerians inherited astronomical knowledge from a more advanced predecessor civilization that didn't survive the last ice age but passed its knowledge forward through oral tradition. Camp 3 says the Sumerians were telling the literal truth when they said the gods taught them, and that those gods possessed technology capable of observing the full solar system. Each camp has evidence it can point to and weaknesses it can't fully address, and that is actually the hallmark of a genuinely open question. If the answer were obvious, this debate wouldn't have lasted 100 years. The fact that it persists tells you the evidence is genuinely ambiguous, and maybe that is okay. Maybe some questions need more time, more excavation, more tablets translated, more astronomical data analyzed before we can say anything with certainty. We've translated only a fraction of the cuneiform tablets that have been excavated, and we've excavated only a fraction of the archaeological sites that exist in southern Iraq. Somewhere in a museum basement, or still buried under sand, there may be a tablet that resolves this debate entirely, but until it is found, we work with what we have. And what we have is actually more extensive than most people realize, because the astronomical tradition didn't end with the Sumerians. It was inherited and expanded by the Babylonians. The Babylonians took Sumerian astronomical foundations and built something that wouldn't be matched for 2,000 years, a systematic predictive astronomy capable of calculating future celestial events with mathematical models. The tablets known as astronomical cuneiform texts, or ACT, contain step-by-step computational procedures for calculating the positions of the moon and 5 visible planets for any date. These aren't observations recorded after the fact. They're algorithms, mathematical recipes that take a starting position and compute where a planet will be months or years in the future. The lunar theory in these tablets uses a zigzag function to model the moon's variable speed, a mathematical technique that wasn't redeveloped in Europe until the late Middle Ages. And their system B for lunar calculations is so sophisticated that historian Otto Neubauer, the world authority on ancient mathematics, called it one of the most brilliant achievements of ancient science. The Babylonians could predict the exact date and magnitude of lunar eclipses, the dates when planets would reach their brightest point, and the precise moments when planets would appear to reverse direction in the sky. That retrograde motion, when a planet appears to move backward, confused astronomers for centuries until Copernicus explained it with the heliocentric model in the 16th century. But the Babylonians could predict when retrograde would begin and end with accuracy that modern computers confirm is correct, without ever stating the heliocentric model explicitly. They had the math right without, supposedly, having the model right. And that paradox is one of the underappreciated puzzles in the history of astronomy. Either they had a better understanding of orbital mechanics than they explicitly wrote down, or their mathematical techniques were so powerful they could generate correct results from incorrect assumptions. Let's talk about the Sumerians and time, because their understanding of deep time is another aspect that doesn't get enough attention. The Sumerians operated with numbers that imply an understanding of time scales far beyond what any agricultural civilization should have needed. The number 432,000 appears repeatedly in Sumerian astronomical and mythological texts, and its significance has puzzled scholars for over a century. 432,000 is exactly 1/60th of the precessional cycle of 25,920,000 years. Wait, let me correct that. 25,920 years. Actually, the relationship is even more precise than that. 432,000 is exactly 1/60th of 25,920,000, which is itself 1,000 times the precessional value of 25,920. The precession of the equinoxes is one of the slowest cycles in observable astronomy. The pole star changes position so gradually that you need centuries of careful observation to detect it. The Hindu astronomical tradition uses the same number. 432,000 years is one yuga cycle in Hindu cosmology, and the full cycle of 4 yugas totals 4,320,000 years. Two civilizations separated by thousands of miles independently, using the same astronomically significant number, is either a remarkable coincidence or evidence of a shared ancient source. The Indus Valley Civilization, which traded with the Sumerians, could be the bridge between these two traditions. But we can't read Indus script, so the connection remains unproven. What we do know is that the number 432,000 is not an arbitrary choice. It has deep mathematical relationships to observable astronomical cycles, and it appears in multiple ancient traditions independently. There is one more astronomical claim we should examine, because it is the one that most directly challenges the assumption that the Sumerians couldn't see beyond Saturn. Several cuneiform texts describe celestial bodies using color terms, and while most match what we'd expect, there are descriptions that correspond to planets not visible to the naked eye. Mars is described as red, which it visibly is, Jupiter as white or bright, Saturn as dark or black, all consistent with naked eye observation. But certain texts describe additional bodies using the terms green, blue, and watery, terms that don't match any visible star, but that perfectly describe the color of Uranus and Neptune, as seen through modern telescopes. Uranus and Neptune both appear blue-green due to methane in their atmospheres, a characteristic that can only be observed through optical instruments. The standard scholarly response is that green-blue is simply a general term for a dim or distant celestial object, and the color match with actual outer planets is coincidental. And that is a reasonable position. Ancient color terminology doesn't map one-to-one onto modern color categories, and overinterpreting color words is a known trap in this field. But combine the color descriptions with the size descriptions and the positional descriptions, and you get a cumulative picture that is harder to dismiss as pure coincidence. Any single claim can be explained away. The cylinder seal is decorative, the colors are metaphorical, the asteroid belt reference is mythological, the mathematical constants are coincidental products of base 60. But when you have dozens of specific claims, each individually explainable but collectively pointing in the same direction, At some point, the cumulative weight demands a better explanation than coincidence repeated 20 times. This is actually how most scientific paradigm shifts begin, with an accumulation of anomalies that the existing framework can individually explain, but collectively cannot. The existing paradigm says ancient civilizations developed astronomy slowly through centuries of patient observation, with no external input and no lost predecessor traditions. And this paradigm works well for most ancient astronomical traditions. The Greek, Chinese, and Maya astronomical developments can all be traced through clear stages of increasing sophistication. But the Mesopotamian tradition doesn't show this progressive development clearly. The earliest substantial astronomical texts already display a level of sophistication that implies a long prior tradition we can't find. Some scholars explain this by pointing to perishable writing materials. Maybe the early developmental stage was recorded on wax boards or papyrus that didn't survive. Others suggest the oral tradition was so strong that the developmental period happened before writing was adopted for astronomical purposes, and only the mature product was committed to clay. Both of these explanations are possible but unfalsifiable. We can't prove or disprove the existence of records that no longer exist, which makes them weak as scientific arguments. The alternative, that the Sumerians inherited a mature astronomical tradition from a more advanced source, is also unfalsifiable, but it has one advantage. It explains the anomalies. Let's address one final topic that connects Sumerian astronomy to the broader question of what this civilization really understood about the universe. The Sumerians didn't just track individual planets. They attempted to model the entire cosmos as a unified mathematical system. Their cosmological model described multiple levels of heaven and earth, each governed by mathematical relationships, with the visible sky as only one layer of a larger reality. The number system they used, base 60, allowed them to work with enormous astronomical numbers without the notation systems that modern science takes for granted. They could express the number 12,960,000,000 in a compact base 60 form that fit on a single tablet, a number that corresponds to the precession cycle, multiplied by a factor of 500. This mathematical capacity suggests they were thinking about timescales and spatial scales that go far beyond what a simple agricultural calendar requires. A farmer needs to know when to plant and harvest. You don't need the precession of the equinoxes for that. You don't need the synodic period of Jupiter calculated to 3 decimal places. The Sumerians invested enormous intellectual resources into astronomical precision that had no practical application for their daily lives. Which raises the question of why. Were they preserving knowledge they had inherited and feared losing? Were they trying to decode messages they believed were written in the sky? Or were they simply driven by the same curiosity that drives modern astronomers? The honest answer is probably a combination of all three, and the proportions of each remain unknown. So where does all of this leave us tonight, lying here in the dark, thinking about ancient people who mapped the sky with a precision we're still trying to understand? Here is what we know for certain, and it is astonishing even without the controversial claims. The Sumerians tracked planetary movements with accuracy that Europe wouldn't match for 3,000 years. They predicted eclipses decades in advance, and they used mathematics of extraordinary precision. Here is what remains genuinely unexplained: the formation sequence in the Enuma Elish matching actual planetary accretion, the debris belt description matching the asteroids, the mathematical constants aligning with precessional values, the color descriptions that match invisible outer planets, the astronomical tradition appearing already mature with no visible developmental phase, and a number system built around values that echo celestial cycles. None of these mysteries prove that the Sumerians had telescopes or that aliens taught them astronomy. But they do prove that our understanding of ancient astronomical capability is incomplete. And in science, incomplete understanding is not a failure. It is an invitation to keep looking. 5,000 years ago, on the flat alluvial plains of what is now southern Iraq, astronomers climbed to the tops of stepped temples and recorded the movements of lights across the sky. They pressed reed styluses into wet clay and wrote numbers that modern computers have verified are correct, describing a solar system they shouldn't have been able to see in the detail they recorded. They did this without lenses, without electricity, without computers, without any of the tools we consider essential for understanding the cosmos. And they got it right. Not perfectly, not completely, but so substantially correct that we're still using their constellation system and their mathematical base to measure time and angles today. Every time you check the time, every time you measure an angle, every time you look at a star chart divided into 12 zodiac sections, you are using Sumerian astronomy. Look at your phone's clock right now, or the alarm beside your bed. 60 seconds in a minute. 60 minutes in an hour. That is not natural. That is not decimal. That is Sumerian. A civilization that turned to dust before Rome was founded embedded its mathematical system so deeply into human culture that we still can't replace it. And they did the same thing with the sky. They mapped it, named it, measured it, and predicted it with such thoroughness that every subsequent astronomy tradition, Greek, Islamic, European, built on their foundation. Whether they achieved all of this through patient genius over millennia, through inherited wisdom from a lost predecessor, or through means we haven't considered, the achievement speaks for itself. The Sumerians knew things about the solar system that scientists still can't fully explain. And that sentence is true, regardless of which interpretation you find most convincing. These mysteries have been waiting thousands of years for answers. They'll wait until morning. Sleep well. And if you dream tonight of ancient astronomers standing on temple tops counting the lights across the heavens, you wouldn't be dreaming of fantasy. You'd be dreaming of history. Sleep well. And if you dream of ancient observatories and star charts pressed into clay, you wouldn't be the first to carry these mysteries into sleep. Before we truly close, there is something worth knowing about the current state of Sumerian astronomical research. Because the field is far from finished. The British Museum alone holds over 130,000 cuneiform tablets, and only a fraction have been fully translated and published. Among those untranslated tablets are thousands of astronomical texts, observational diaries, computational procedures, and star catalogs that no modern scholar has ever read. The Iraq Museum in Baghdad holds thousands more, many damaged by looting and conflict, some still being recovered and pieced back together by dedicated conservators. Every year, new tablets are published, new translations appear in academic journals, and occasionally a single new text overturns decades of assumptions about what the Sumerians knew. In 2015, a Babylonian tablet was found to contain a method for calculating Jupiter's position using a technique that historians had previously attributed to 14th century European mathematicians. The tablet showed that Babylonian astronomers used a geometric trapezoid method to compute planetary displacement, a technique that anticipated integral calculus by over 1,000 years. This wasn't a fringe claim or an alternative interpretation. It was published in the journal Science and confirmed by multiple independent experts. It means that even now, in the 21st century, we're still discovering that the Mesopotamian astronomical tradition was more advanced than we previously believed. And this is perhaps the most important takeaway from everything we've discussed tonight. Our picture of what the Sumerians knew is not complete. It is actively being revised, and every revision so far has moved in one direction. Upward. We keep finding out they knew more than we thought, calculated better than we assumed, and observed more carefully than we gave them credit for. If that pattern continues, some of the claims we currently dismiss as impossible may turn out to be merely ahead of their time in our understanding. The Sumerians were not primitive, they were not simple, and they were not making it up as they went along. They built a civilization that invented writing, mathematics, law, astronomy, and urban planning, and they recorded their understanding of the cosmos with a precision that still demands respect. Whatever they knew about the solar system, whether it was everything the alternative researchers claim or something more modest but still remarkable, they knew enough to change the world permanently, and they wrote it all down on clay, the most durable writing medium ever invented, ensuring that their knowledge would outlast every empire that followed them. 5,000 years later, we're still reading it, still checking the math, and still finding they were right more often than we expected. That is the real mystery, not whether they had telescopes or alien teachers, but how a civilization working with nothing but clay, reeds, and human intelligence achieved results that we sometimes struggle to explain even now. Go outside tomorrow night and look up. The same planets they tracked are still there, following the same orbits they calculated, in the same positions they predicted. The Sumerians mapped the heavens 5,000 years ago, and the heavens haven't changed. Only our understanding of what those ancient astronomers really knew. Somewhere beneath that ancient sand, More tablets are waiting, and maybe the next one dug up will be the one that finally explains what the Sumerians really knew. The Queen of Heaven still rises where their tablets said she would, still following the 587-day cycle they measured with reed styluses and oil lamps. Jupiter still completes its circuit in the 399 days they recorded. Saturn still moves with the steady patience they described, and Mars still burns red exactly as their tablets warned. Every orbit they calculated still holds. Every eclipse they predicted still falls on schedule. Every star they cataloged still occupies its appointed place. And beyond Saturn, in the dark space their tablets may or may not have described, Uranus turns its blue-green face in the cold, Neptune traces its vast slow orbit in silence, and the asteroid belt drifts in the gap they called the hammered bracelet. Whether the Sumerians truly knew about those distant worlds, or merely left clues that we've interpreted through wishful thinking, the question itself honors their legacy. Because the fact that we take their astronomical claims seriously enough to debate them 5,000 years later is the greatest testament to what they achieved. Sleep well, and if you wake in the night, look out the window. The same stars are there, the same planets are moving, the same mystery remains. Good night, and thank you for spending this time with the oldest astronomers who ever lived and the questions they left behind for us.